Number 1, divide the number line into the given fractional unit, then place the fractions. Write each whole as a fraction. So looking at my number line, I see that I have 0 through whole number 3. We're dividing each section into fourths. So I draw 3 lines to make 4 equal sections. I'm estimating to make those all equal sections because I'm not going to take the time to measure that. So I have to put 2/4 on my number line. I have to number everything, but then we will go back and highlight those. So this would be 0/4, 1/4, 2/4, 3/4, and 4/4 brings us to our first whole. 5/4, I'll prefer 4. 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4, and obviously your writing is much neater on your paper. I'm going to take my yellow pen and I'm going to go back and circle, kind of highlight my fractions that I placed on the number line. And I wrote each whole as a fraction, 4/4, 8/4, and 12/4. Now, looking at number 2, I'm going to use the number line above to compare the following fractions using the greater than, less than, or equal to sign. So 3/4 compared to 5/4. So here's 3/4, there's 5/4. 3/4 is closer to 0. It is less than 5/4. 7/4, which I circled, compared to 4/4, which is 1 whole. 7/4 is greater than 1 whole. This is also equal to 1 whole. This would be 3 wholes here, or go right off to the side, that's also 12/4 compared to 6/4, and 3 or 12/4 is greater than 6/4. My arrow at the bottom of the page tells me I need to go to the next page to complete this exit ticket. Number 3, use the number line from problem 1, which is larger, 2 wholes or 9/4. So if I scroll back up and I had my number line still written on, I would see my number line that was labeled through 3, and I would know that 2 wholes is 8/4 because 2 times 4 is 8, or I could think of it as 2 groups of 4 equal pieces means I would have 8 equal pieces, and then another fourth in between, another fourth would give me 9/4. And so therefore 9/4 is greater than 2 wholes, because 2 wholes is equivalent or the same as 8/4, which is less than 9/4. Lesson 20. Label what fraction of the figure is shaded, then circle the fractions that are equal. So what's super cool about this problem is that this isn't what we've mostly seen, but all of these pieces are equal, and so that helps me to think about how these can be fractions. So there are 1, 2, 3, 4, 5 pieces, and 3 of them are shaded. So 3/5. I have 1, 2, 3, 4, 5 pieces, and 3 of them are shaded. My and got ahead of my brain. So those 3 out of the 5 are shaded. I have 1, 2, 3, 4, 5 pieces, and 2/5 are shaded. I have 1, 2, 3, 4, 5 pieces, and 3 are shaded. So these 3 fractions are equal or equivalent, or just another way of saying that they are the same, even though they look different. Each of them has the same size pieces and the same amount of pieces are shaded out of the whole. The denominator is also the same number of equal pieces. So the arrow tells me I must go on. It says label the shaded fraction, draw 2 different representations of the same fractional amount. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my denominator is 11. I have 11 equal pieces, and 1, 2, 3, 4, 5 are shaded. So I can draw this any other way. So maybe I do start with tape diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to draw that extra piece. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces, and I'm going to shade 5 of them. Then maybe I do it with some triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Get rid of my little extra piece there, and then I will shade 5 of them. 1, 2, 3, 4, 5. And those are all equivalent. They're all same. They're just different representations of the fraction 5/11. Now let's look at B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my denominator is 10. 10 parts make the whole. 10 equal parts make the whole. And I can see that 1, 2/10 are shaded. I could do this in different ways as well. For time and for my drawing purposes, I'm going to do another box. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'm going to shade in 2. But the best part is it could be any 2 because they're all the same size pieces. And then maybe I do my triangles again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Get rid of my extra. And then I can shade in 2, and it could be any 2. And 2/10 are shaded. Awesome. Let's move on. Number 1, Claire went home after school and told her mother that 1 whole is the same as 2 halves and 6 sixths. Her mother asked why, but Claire couldn't explain. Use the number line and words to help Claire explain why 1 equals 2 halves and that is also equal to 6 sixths. So I'm going to use the most amount of space I can. And I am going to start at 0. I'm going to go to 1. And I'm going to start by splitting it into halves. And I'm going to label that. So this is 0 halves. This is 1 half. And 1 half being this equal space there. And then to get over here, that would be 2 halves. It means I have all of the parts, all of the equal parts that make a whole. So the whole had been split into 2 equal parts. I have all of them. 2 halves equals 1 whole. Now if I split the same number line into sixths, confused myself a little bit, so I'm going to go back and just draw this back in, because I stopped here thinking this was 1 before, so I need to give myself some more space. So 1, 2, 3, 4, 5. Get rid of some of those extra marks. My apologies for any confusion. Just needed to give myself some more space, and mistakes are okay. They help us learn and grow. So here I can see that this would be 0/6, 1/6, 2/6. 3/6 is the same as 1/2. Means I have half of the pieces I need to make 1 whole. 4/6, 5/6. And now I have 6/6, and that is the same as 1 whole, which is the same as 2 halves. It's because the whole is being split into those equal parts. It doesn't change the amount you have when you end. It's just changing the size of the pieces you split it into. So whether it was 1/2 or 2 halves to get to the whole, or 6 equal pieces called sixths, that way you knew you were complete. And that's how Claire could help explain it to her mom.